Now look, this is our question, and in this question we have to calculate R, that means the load resistance, which will absorb maximum power from the circuit and compute maximum power. We will compute maximum power by using the formula, that is P equals to V square by 4RL, or V square by 4R EQ. Here EQ means the total equivalent resistance. Now look this circuit. This question is little bit tricky. In this question, the load resistance provided in the middle of the circuit. Okay, so we have to convert this circuit in simple form so that we can understand it so easily. For simplification, we will move this resistance towards left side and also this source 6 ampere source into the left side. Okay, so after that the circuit will look like this. Okay, so we have shifted this 5 ohm and this 6 ampere source in the left side. Okay, and this is the terminal. Now we have to convert this circuit into Thevenin equivalent circuit, and then we have to determine VTH and then RTH. Okay, we actually convert this voltage source into current source to make our calculation easier. Okay, so that's why we will convert this voltage source into current source. So for this conversion, the value of the current source would be, suppose that is I. Okay, so I would be V by R. Here V is 120 and R is 10, so I would be 12 ampere. Okay, so we will convert this voltage source into current source, which value would be 12 ampere. Okay, now we have to convert this voltage source and resistance into current source. Okay, so after conversion the circuit is look like this. Here this is the current source having value 12 ampere and the resistance 10 ohm in parallel combination. Okay, so this is B. Now look, in this circuit, this path and this path, all this path have no elements. Okay, so we can merge these paths. Okay, so after merging this path, the circuit will look like this. Okay, now this is the circuit, and we will apply nodal analysis method in this circuit, in this node. Okay, now for this node, first of all we will apply KCL. Okay, suppose we assume the direction of this suppose we assume the direction of the current in this 10 ohm branch is in this way. Okay, and also in this 5 ohm branch current is in this way. Okay, suppose here value is I1 and 10 ohm resistance, and for 5 ohm resistance the current is I2. So we will apply KCL here. So after apply KCL, the equation would be, here all these 4 current is inward in this nodal. So the equation would be 10 plus I1 plus I2 plus 6 equals to 0. So this is our KCL equation. Now we will find I1 and I2. Okay, look, in this branch I1 is passing from B to A, so I1 would be BB minus BA. Here BB means the voltage drop across the B point, and BA means the voltage drop across this A point. Okay, so the I1 would be VB minus VA divided by the resistance. Here resistance is 10, so it would be 10. And I2 is, again, I2 is from B to A, so it would be VB minus VA divided by the resistance. Here resistance is 5. Okay, 5. And 10 would be as it is, and here 6 would be added as it is, equals to 0. So 10 plus, now look, in this case we have to find VTH, that means VAB, voltage across this two terminal. Okay, so here VBA, here VB minus BA means VBA, so now we will take a minus sign. Okay, so it would be VA minus VB by 10. So we know that VA minus VB is VAB, so that's why we have taken this minus sign here. Again we will take minus sign, so the equation would be VA minus VB by 5 plus 6 equals to 0. So here 10 minus VA minus VB equals to VAB, or we can write it as VTH by 10 minus VTH by 5 plus 6. Okay, sorry, here value is, sorry, in this case the value of current source is 12. Okay, so it would be not 10, it would be 12. It would be 12. Okay, so now 12 plus 6 is 18 equals to VTH divided by 10 plus VTH by 5. So here 18 into, if you take 10 as common, then it would be VTH plus 2 VTH. Okay, then 3 VTH is 180, so VTH would be 60 volt. So here we have find the value of VTH. Now we will calculate the value of RTH, that is Thevenin equivalent resistance. For calculating the value RTH, we will make these two source, this 12 ampere source and this 6 ampere source, as open circuit. Okay, after that we will find RTH. Now we have draw the circuit for find the value of RTH. Here look, this 12 ohm resistance become short circuited, and this 6 ampere source became short circuited. Okay, you can see. Now we will find RTH, or you can say REQ. So it would be, look, 10 and 5 ohm both are in parallel combination, so it would be 10 into 5 divided by 5 plus 10, that is 15, 3. So it is 10 by 3 ohm. So this is the value of RTH. Now we will draw the Thevenin equivalent circuit. So this is the Thevenin equivalent circuit, and in this circuit, to gain the maximum power by this load resistance, the value of the load resistance should equal to the value of network's equivalent resistance. Okay, so RL should be equals to REQ. Okay, at that case we will gain maximum, so at that case we will get the maximum power. So that's why the R value should be 10 by 3 according to the maximum power transfer theorem. Now we will find the current. Okay, here current I is VTH by total resistance RTH plus RL. Here both are same, so you can say VTH by 2 RL. VTH into 2 RL means 2 into 10, that is 20 by 3. Here VTH is 60, so 60 into 3 by 20, it is 9 ampere. So we have calculated the value of I, that is 9 ampere. Now we will compute the maximum power. Okay, so maximum power P max is equals to, we know that, V square by 4 RL, or you can say V square by 4 REQ. So it would be V square. Here V means the VTH. VTH value is 60. 60 square by 4 to RL. RL value is here 10 by 3. 10 by 3. So after calculating, the P max would be 270 watt. And this is our answer. So you can see in this type of question, we have to first convert this circuit into Thevenin equivalent circuit. After that we can find maximum power. Okay, so easily. Hope you understand this process, and